Peace. Shalom. Hutta. Welcome back for Chapter 7 of Balls of Fire. And actually, Spring Training 7. A trinity of natural patterns. Don't forget the screenshot if you would like to read along. Also, don't forget to like, comment, and subscribe. Your feedback is greatly appreciated. A trinity of natural patterns. The cosmic microwave background, CMB, is a relic from the early universe. Scientists represent it as a complex system of warm and cool spots or lobes projected onto the celestial sphere around Earth. The patterns, which reflect large-scale structures present in the early universe, line up with the solar system in strange and as yet unexplained ways. Dragan Hudaher. Why is the solar system cosmically aligned? Today, the knowledge of the elite has survived and is preserved in great works of art and literature, as well as contemporary science. With their knowledge and power, perhaps the elite activated the cycle of the great cosmic system at a death transition. And those without this knowledge who do not question the motivations of authority, the normalized, the altruistic, the sacrificial dissipating flux of the great process, may they rest in peace if that is possible. Either one takes the time to understand natural processes or one does not. This is the key because human history documents the numerous religions and mythologies have primed human beings for altruistic sacrifice through the promise of eternity, while nationalist governments have awarded gold and silver medals to soldiers for altruistic suicide and warfare. Consider that proteins are workhorses that turn a gene, bits of DNA, on or off. Lambda C1 and Crow proteins fold and bind to DNA to turn genes on or off, and these particular proteins function through two funnel protein energy landscapes that are similar to a tiny biological black hole connected to a white hole that casts out matter or goes backwards in time. In the interest of understanding this ancient Egyptian biophysical interpretation of funerary texts, let's review protein energy landscape theory. In recent years, energy landscape theory has become an important tool linking three disciplines, as can be seen in the cooperative work of biologists Charles L. Brooks III, physicist Jose Unichik, and chemist David J. Wells. An energy landscape is a potential energy surface defining the folding of proteins, the complex behavior of gases, and the structure and dynamics of atomic and molecular clusters. The protein energy surface has topographical features similar to the Earth's landscape, such as mountains, valleys, and hollows. However, the dimension is much higher, and the energy landscape determines the behavior of the system. The classical view of protein folding, established by Cyrus Leventhal, asserts that proteins cannot fold by random search for native correctly folded state. So, to save time, they fold by a sequential energy bias folding pathway. On the other hand, proteins with random amino acid sequences encounter a rough potential energy surface or frustrated system. In ancient Egyptian texts, the second death in their black hole netherworld, Duat represents a random, frustrated protein system, while knowledge of the sequential energy biased folding pathways allows the dead king to reach the native state. I'm going to take a look at these figures real fast because we're in that mood. Figure 7.1, a rugged energy landscape with kinetic traps, energy barriers, and some narrow throughway path to native state. Folding can be multi-state. In figure 7.2, the moat landscape to illustrate how a protein could have a fast folding throughway process. A in parallel with a slow folding process, and B involving a kinetic trap. Permission to use both images from Ken A. Dill and Hugh Sun Chain, 1997. In figure 7.1, we see what appears to be a circular cone of mountains and carnivorous valleys pierced to its center by a hole in the shape of an irregular cone or funnel. The protein folds itself along a free energy surface resembling a rough funnel. What is very similar to the construction of a tiny black hole. Peaks represent the highly fit forms. Populations of organisms driven by mutation, recombination, and natural selection struggle to climb toward those high peaks. In figure 7.2, the faster folding process A avoids the kinetic trap represented by the moat around the axis that slows down the B folding process. Natural selection, the central Darwinian view of evolution, sifts through useful variations among mutations and have random effects on organisms. Evolutionary adaptation is a process of hill climbing on a fitness landscape. A random change in the genome or the organism's DNA and genes slides a mutant higher or lower on the mountain terrain. Stuart Kaufman explains there are pathways uphill to the distant peaks and natural selection in sifting for the fitter variants pulls the population up towards them. Kaufman explains that this was explained as a gradualism or gradual ascent at work in Darwin's sense, in that the fitness landscapes are correlated. Ancient Egyptian texts clearly describe the quantum misfortunes of those without knowledge who travel on a random, rugged energy landscape with kinetic traps and energy barriers rather than the fast folding axial pathway traveled by the pharaonic elite. Kaufman gives us a good description of the dilemma a population of organisms might encounter a rough, random landscape. And he reads, random landscapes have a hyper-astronomical number of local peaks, it begins to be obvious why adaptive search on random landscapes is very hard indeed. Suppose we wanted to find the highest peak. We try to search by climbing uphill. The adaptive walk soon becomes trapped on a local peak. The chance that the local peak is the highest peak, the global peak, is inversely proportional to the number of local peaks. On random landscapes, finding the global peak by searching uphill is totally useless. We have to search the entire space of possibilities. But even for modestly complex genotypes or programs that will take longer than the history of the universe, try to evolve on a random landscape seeking the highest possible peak, and the population remains boxed into an infinite small region of the space of possibilities. In these random moonscapes of possible or impossible cliffs soaring and plummeting in every direction, no clue exists about where to go, only the confusion of hyper-astronomical numbers of local peaks, pinnacles studded into the vast space of possibilities. No pathway uphill led further than a few steps before the stunned and dazed hikers ascend to some minor peaks, one of so many that the stars in the sky are a minor number by comparison. Start anywhere climbing uphill, and one will remain frozen in the tiny region of the space forever. The ancient Egyptian pharaonic priesthood understood evolution as happening on a non-random protein landscape. A protein folding from a set of instructions from a gene is a non-random landscape. The protein instructions demand that the protein go uphill to the highest peak and turn the gene on by an adaptive walk on an ordered fitness landscape. That vertex or genome type is the uphill goal, and the Egyptian texts refer to the vertex often. The vertex is the highest peak, the global optimum, the global peak. To see how proteins function, we can understand the fitness of the genotype as a height that the protein climbs to turn on the gene. A theoretical biologist Stuart Kaufman explains evolution requires landscapes that are not random, and ancient Egyptian science supports this. Individual selective pressure allows evolution. The basic idea is that at a depth transition, we need new traits to be fit in the quantum universe. And so morphogenesis, or the emergence of new form and structure, is essential. Our fitness may depend on HGT and recombination mediated by the genomic network of a virus such as phage lambda, so we can acquire the traits we need for the new quantum environment. Kaufman states the genomic network, I believe, lies in the ordered regime, perhaps near the edge of chaos, because such networks are readily formed, part of order for free, but also because such systems are structurally and dynamically stable, so they adapt on correlated landscapes that are able to be molded for further tasks. Egyptian texts support that lambda C1 and crow proteins are entangled like a vortex or anti-vortex pair, and the ordered regime is crow proteins in their axial vortex or horizon that is surrounded by the chaos of C1 proteins folding funnel landscape. Ancient Egyptian texts stress the importance of crossing over, that is, recombining or exchanging DNA for continuity by HGT. As Margulis and Sagan stress, the speed of recombination is superior to mutation. On sex and recombination, Kaufman agrees that fitness increases far more rapidly when mutation and selection are used to climb the peaks, along with recombination for exploring the genotype space for adaptation. Kaufman explains that the recombination is useless on a random landscape, so a landscape must be well correlated. Also, he considers that evolution may depend on the system being able to organize itself spontaneously. Ancient Egyptian texts also confirm Kaufman's last point for self assembly and self organization, jumpstart the biological process, followed by recombination and mutation. In addition, ancient Egypt and other early cultures describe the sign of emergent order as a process of crystallization.